Following are examples of adding and subtracting rational expressions. Well, I started off by showing an example of a fraction 1 over 21 plus 3 over 7. And with that example, I went about showing how to find the LCD. Well, we took 21 and 7, which were the original denominators, and we factored them out into primes. Well, here we have 7 times 3, and then 7 over here times 1. 7 is already a prime number. So we take the 3, which is in our 21 fraction, and also multiply it to the 7 so that we can get the common denominator. And that's where we get the new fraction over here, where originally it was 3 over 7. So now we're taking the 3 from here to multiply it to both the numerator and the denominator so that we can come out with our new fraction, which turns out to be 9 over 21. And then in that case, we can add the two fractions together because we have a common denominator. In another example, we have 2 over 5x plus 2 over 10x squared. Now, finding the LCD involving those two, which is 5x, our denominator 5x, and 10x squared. We factor them out again into primes, 5 times x here, and then 2 times 5 times x for the 10x squared. Well, in our first denominator, which is 5x, we look at what's missing compared to the 10x squared denominator. Well, what was missing was the 2, the factor of 2, and also another factor of x. So we have to multiply 2 times 5 times x to get our common denominator. So the common denominator turns out to be 10x squared in this case. And notice that in our other denominator, which is 10x squared, well, we already had a 5 there, and we already had an x, so we didn't need to multiply that by any other factors. So 10x squared is our common denominator. And we go back to our original fraction, and we multiply what was missing to our numerator. So again, for 5x, the 2 times x was missing, so we multiply our numerator by that, and we get the new fraction of 4x up top. So now we can write everything over our common denominator. So 4x plus 2 over 10x over 10x squared. We factor out the top of our fraction, factor a 2 out, and then at that point we can say 2 goes into 10 5 times, and that's going to leave us with 2x plus 1 over 5x squared. In a similar example, we have 5 over 6x squared plus 4 over 5x to the 5th power. Again, finding our LCD, we factor out the 2 into primes. So 6x factors into what we see here, and 5x squared factors into 5x to the 5th power rather factors into what we see here. And looking back at our first factors, well, what's missing in there is a 5. What's missing in the 6x squared is the 5 and 3 extra x's. So we take those and multiply it to what we originally factored. So the 5 times 2 times 3 times x, and then the extra 3 powers of x there. So our common denominator after we multiply everything becomes x to the 5th, 30x to the 5th power. And if we look back at our denominator 5x to the 5th power, well, what was missing in here was the 2 times 3 from the other factor. So we take that and multiply it to our factors, and we have, again, 30x to the 5th power from that. When we determine what's missing in one numerator, we multiply the top part of the fraction by that. So in our first fraction, which was the 6x squared, the numerator there, we multiply that by the 5 and x to the 3rd. So the first fraction, again, gets multiplied by 5x to the 3rd there. The second one gets multiplied by the 2 times 3, which was there, which becomes 6, of course. So, 4 times 6 is what we do there. And both can be now written over the common denominator. So 25x to the 3rd plus 24 over 30x to the 5th. We can't factor anything else out of that. In another example, we have x plus 2 over x plus 8 over plus x minus 4 over x plus 7. The LCD is just multiplying the two together. And once we do that, we can find the new fractions for the problem is by taking whatever we have over on this side, which is the x plus 7 in this case, and then multiplying it by the numerator there. So that's what we do there. And then same thing here. We take the x plus 8 and multiply it by x minus 4. And that's what we see in this part written over our common denominator. We use the FOIL method to come out with the results of x squared plus 7x plus 2x plus 14 plus x squared. So we basically use the FOIL method on both these here, and then go back and combine the like terms. So when we combine the like terms, this is what it turns out to be: 2x squared plus 13x minus 18. We would try to we should also try to factor this out to determine factor the top part of the fraction out to see if we can cancel anything there. But the top part doesn't factor as prime, in fact, so we can't do anything further with that. And this is as far as we can go. Now, in subtracting, we have an example here of 8 minus 3x over x minus 4. Our common denominator is our least common denominator is x minus 4. Keep in mind that we can write the fraction, the 8, as a fraction by putting a 1 in the denominator or writing it over 1. So 8 over 1 minus 3x over x minus 4 is the same thing as what we started with. So given that, we take our the common denominator and write them over each one of the fractions, and now we can multiply what was missing. So the x minus 4 gets multiplied to the top part of the fraction as well, but over so it becomes well, the 3x over x minus 4 stays the same because x minus 4 is the common denominator. And at this point, we can distribute the 8 into the first term so that we can combine like terms. And our final result is 5x minus 32 over x minus 4.